In the first few samples, I'm going to use these polygon shapes. These define a couple of rectangles. I'll go ahead and execute that code, and there are the two shapes. Make that a little bit bigger there. Okay. So this just shows a couple of overlapping shapes. So one of the things you can do with these two shapes is to create a new shape that contains all of the points in one shape that are not in the second shape. And to do that, you can use the ST_difference method. And that performs the calculation. All right. So all I'm doing is, once again, defining those same two polygons. I keep repeating the code, so it makes it a little bit easier to run it as just a small unit. But you could save this in a table or do whatever you want. And then I'm going to use P1, do the difference with P2, and then I'm also going to return the well-known text. All right, go ahead and execute that. And there's the result, and there you can see the well-known text. And so it's 6040, 440, 400. Obviously, there's some rounding errors there and so forth. But here are the results. So this is the difference between, it's all of the points in that one shape, that large blue lower shape, excluding all the points that are overlapped. So in fact, if I run this again, just so you can remember what that looked like. So the result of that calculation using ST_difference were all the points here and there, excluding the ones that are overlapped with that second shape. And there you have the results. Now, another way that you could approach the same issue is use code like this that superimposes the difference rectangle over the original rectangles. So here what I'm doing is, once again, working with those same two shapes. I'm doing union all in order to select both those original shapes, and then I'm doing another union all with that difference. And there you have that. There's the results. And there, the darker shape here is that difference rectangle. So a spatial viewer has some limitations in how it can display that. But other tools might make it easier to work with those different shapes and see each shape individually. Okay, but this works for our purposes here. But again, the thing to understand here is that I'm really just doing this union all in order to display these shapes within the Spatial Results tab. Okay, then another thing you can do is create a shape that bounds the overlapping area between the two shapes. So this is the overlapping area. So using the same polygons, and then I do select P1, and here I'm passing in a second parameter just as an empty string, or not passing a parameter, but returning a second field with an empty string. Union all, the second shape there, and then doing the intersection of the two. And so this is going to be the difference, this area right here. So it's the intersection of these two rectangular shapes. And then I'm also returning that well-known text. So that's why I had to include these empty strings, because when you union together, you have to pass the same number of fields. Execute that. And there you have the well-known text for that resulting polygon. And there, the darker shape now is the intersection of those two shapes. All right, then yet another variation is to get an object with all the points that are either in one shape or another, but not the points that are in both shapes. And for that, you use the ST_difference method. Again, same two polygons. And then you just use SIM_difference, and then here's returning the well-known text. Execute that. Now it's a multi-polygon, because this is no longer just a regular polygon shape. And you can see that when we come here. So this is a single shape, but it actually contains multiple polygons. So that's how SQL Server chooses to define this. And if you look at the well-known text, you can trace around the different locations and the points and see how it calculates that. And just keep in mind that a multi-polygon is just a collection of polygons, and in this case, two of them. Okay, then yet another variation is STUnion, which returns an object with a set of all points that are within the two shapes. Okay? So it's essentially including all of the points in both shapes and essentially tossing out the overlapping area. It doesn't count those points twice. Execute that. There's the result there. And there's the result. So you can see that it's bounding the outside perimeter of that shape. Okay, so this is a polygon, and it's a fairly complex one, so it has a number of points, but all it's doing is it's tracing around this outer perimeter to point from point to point to point. What's interesting about this is that you can apply many of these kind of interaction methods to different shapes, not just two shapes of the same kind. So in this next set of code, the code defines a rectangle and a line, so a polygon and a line string. And then it uses the various methods to find the difference, intersection, and union for the shape. Okay, so it first of all shows the shapes themselves. So it's just doing a select P, union all, select L. P and L are the polygon and the line. And then it's doing a second select statement in order to get the difference between them as the difference object, the intersection as intersection, and union as union. All right, so I'll execute this. And you can see that we get two result sets. Makes sense, I have two select statements. And then I also get two sets of shapes here in the Spatial Results tab. All right, so this first one shows both of the shapes. So you can see I just have a line that overlays a square. And then this lower part shows the difference. So in this particular case, it's showing the difference between the two. What's in the line that isn't in the rectangle? And so it's just two portions of the line. Now if I go back over to the results, notice that I didn't get a field with multiple objects. I got three different fields. And so the Spatial Results tab can only show one of those results at a time. So in this case, it's showing the difference. But here's where I can use this Select Spatial Column drop-down list to look at the intersection. So these are the intersection of the points. And then here's the union that includes all of the points within both shapes.